Hi, we're going to go over lesson 2.2 today. It's over conditional statements. So as I know the notes are filled in, but I'm going to explain it as I go. So this chapter is going to be very different from chapter 1. Chapter 1 was, hey, let's learn about basic vocabulary. Let's draw points, lines, and planes. Let's learn about new angle types. Chapter 2, it's almost like, it is a complete switch. We're going to learn about logic. We're going to learn how to write sentences in different forms, if those sentences are true, if you can prove them false. So just give it a chance. It's going to be different. It will be okay. You will be fine. We're going to start with something called a conditional statement. Now, as a parent, or as a teacher, you say these all the time. If you get your homework done, then you can play on your phone. That's a conditional statement. Conditional statements are written in if-then form. Now, the arrow here in the middle means it's the transition from the if part to the then. So you have to have both parts. You can't just have one or the other. Now, again, this has some new vocabulary in it. Now, there are two parts to the sentence. The if part is called your hypothesis. So everything in that first part of the sentence, if I say, hey, where's the hypothesis? You're not going to say the if, but you're going to tell me everything following it. So if I would say, if you complete your homework, then you can play on your phone, the hypothesis would be not the if, but you complete your homework. So it would start with the you complete your homework. That's how it would end. Okay, so the second part would be the then, and that is your conclusion. So my conclusion was, then you can play on your cell phone. So just the conclusion, you take the then off, and it would just, you can play on your cell phone. Now, you get to be devil's advocate, and this is fun for some people, and some people have a hard time with it. So each conditional statement has a truth value, true or false. To show the conditional statement is true, you must show that every time the hypothesis in the conclusion is also true. So if you find even one instance where the hypothesis is true, but the conclusion is not true, you have found something called a counterexample. And that's important. If you can show me just one counterexample that proves it false, then you did your job. You proved it false. And so even if you can prove it true like 1,000 times or 1,000,000 times, it doesn't matter as long, if you can prove it false once with a counterexample, then it's false. So it doesn't matter how many times it could be true. It matters how many times you can prove it wrong or false. So as we write this, you will see in the conclusion, in the second part, we really don't want to use the word it or they because we don't really know what it or they is referring to. And so I try to just leave it out in the first part and in the second part. Now, sometimes there's no other word to use, and that would be okay. And so we'll talk about it as we go. So we're going to write each conditional statement, identify the hypothesis and the conclusion, determine the truth value, and if false, provide a counterexample. So there's a lot there. There's a lot of vocab words already, so conditional statement, we know that's a sentence in if-then form. Well, it's nice because they already did that on example 1 here. And then, label the hypothesis and conclusion, hypothesis first part, conclusion second part. Determine the truth value, which means you're going to tell me if it's true or false. And if it's false, you have to tell me why by showing a counterexample. So remember, when you do this, the hypothesis and the conclusion do not include the words if and then. So I want you guys to notice I did not circle or highlight the if or then. And I just abbreviated H and C for hypothesis and conclusion. And down here, if they have you write it out like this, I'm okay if you just circle and label. because you're still getting the idea across and your hand won't cramp because you will have a lot to write. So your counterexample. If a number is divisible by 3, then it is odd. Can you ever prove that wrong? And they did here. They said the counterexample is 6 because it is divisible by 3, but it is not odd. Are there other examples? Sure. What about 12? Is 12 divisible by 3? But it's even. It's not odd. So there's always more than one counterexample. Maybe. So don't worry if you have one and your friend has a different one. It's going to be fine. It's okay if you have different. Okay, so they gave you a new sentence here. This is called a conditional statement again. You're going to write it in conditional statement form. So guys, this isn't a trick question. If they already have the if and the then, it's already in the form for you. So you just rewrite it. Now, notice on here it says list the hypothesis, list the conclusion. Again, I'm okay if you just circle the part like I did here and label. I get the idea if you know it or not. Now you're going to tell me every time if you have this equation, x minus 3 is 5, do you always get 8? And no matter how you do it, if you add 3 to the other side and you solve for x, you always get 8. So this is true. Now, part C, it's a little different now because if you look at the sentence, this is not conditional statement form. So you have to write it in conditional statement form, which means you have to start with the word if, and halfway through you have to use the word then. And your final sentence that you write has to have the same meaning as the one they provided you in part C. Because sometimes when you write it a different way, it has a different meaning. So this sentence says, all right angles are 90 degrees. Now notice I didn't say if it is a right angle, because what is it? So note it. If the angle is, now I could say if the angle is a right angle, I just chose to write if the angle is right, then it's 90 degrees. And that has the same meaning as the conditional statement. So I'm good. Now notice I circled and labeled these as my hypothesis and conclusion. I actually put the little letter up here. I need to decide every single time you have a right angle, is it always 90 degrees? And of course, that's true. So I put true. For part D, is it in conditional statement form? And hopefully you're saying no, because it doesn't start with the word if. The word then is not halfway through. So the sentence says, all supplementary angles form a linear pair. Okay, this is vocab from chapter 1. If you need to go back and look up those words, please do. There is a distinction between them. The distinction is all supplementary angles are not a linear pair. All supplementary angles form a linear pair. That is not true. Oh, wow, that would be why it's false. Great. So all linear pairs are supplementary. That is the difference, guys. So this sentence says, if the angles are supplementary, then they form a linear pair. Now notice, a little hint is like the information at the beginning of the sentence, I keep at the beginning. Information at the end, I leave at the end. It really does help. And when you're finished, you just have to make sure they have the same meaning. So if you remember linear pairs, they have to be adjacent and equal 180. Supplementary just means they're two angles. They could be adjacent, but they don't have to be. And so that is the difference here. So notice I said they're false, and you have to explain why. And I said the angles could be non-adjacent. So that one is a little tricky. Now here's the problem. We really don't know that much geometry at this point. And the geometry you're probably still a little hesitant on. So they're also going to throw in questions about maybe basic knowledge information, which may actually not be basic knowledge for a lot of people. So over the years, like, F, it's about football. Some people don't know anything about football, and I'm one of those people. And, this was talking about dolphins. We live in Indiana. You may know nothing about dolphins. So, we just can do what we can do. Because if I give you too much math, you're going to say you don't understand it. But if I give you basic knowledge, you may not know it. So ask questions if you have them. Look it up on the internet. Again, you will be okay. I promise. Everyone has lived in prior years doing this. Okay, let's read the sentence. Is this, first of all, in conditional statement form? You're going to say no, it's not. It says a dolphin is an animal. That is a mammal. So I need to rewrite it, start with the word if. If the animal is a dolphin. Again, I am not going to say if it is a dolphin, because what is it? If the animal is a dolphin, then it's a mammal. Now, I did use it in the second part. Now, because I've already told what it is. What is it? It is right back here, guys, it is a dolphin. If you want to say dolphin twice, then you can. You can say if the animal is a dolphin, then the dolphin is a mammal. That would be fine. Okay, so moving on, you're going to decide, is that true or is that false? And a lot of people are saying, I have no clue. As far as I know, I do believe that is true. Just ignore what I wrote and crossed out. I think what I was trying to show here earlier is that if you accidentally wrote it backwards and said if the animal is a mammal, then it's a dolphin. Guys, that is not the same sentence as the one up previously that I did in this, highlighted with blue. Because if I say the animal is a dolphin, or if the animal is a mammal, then it's a dolphin, I'm saying every mammal on the face of the earth is a dolphin. And that is definitely false. So you have to be careful how you write the sentence. All right, next one. If you play football, let me start over. You play football if you are a quarterback. Now, this is a tricky one, guys. This deserves purple right there. That's tricky because if you look at it, you're going to say that's not conditional statement form. And it kind of isn't, but it kind of is. Do you see the word if right there that I'm highlighting yellow? If we have the if, this is where we're going to start. We're going to say if you are a quarterback and then jump back to the beginning, then you play football. Because it doesn't make sense if I say if you play football, then you're a quarterback. Because otherwise I'm saying every single person that plays football is a quarterback. That's simply not true. And I know nothing about football, and I know that's false. So when I rewrite this, and of course I abbreviate quarterback, I said if you are a quarterback, then you play football. Guys, that is true. Now, I had a kid in class that told me that was false because of rugby. I personally, again, know even less about rugby than I do football. I don't know if there's something called a quarterback in rugby. So I really think it's the true statement. And again, it's one of these things, maybe it's common knowledge, but it's not common knowledge for this math teacher. So I'm going to say it is true. Cross that out. All right. Looks like my pen went crazy here. Write a conditional statement. Identify the hypothesis and conclusion and state your truth value. So we're doing the same thing here. Just I don't have all the pretty lines and everything for you. So let's do the first one that I didn't previously have completed. It's not conditional statement form because it doesn't start with if. So can I say if the angles are congruent? No, I can't. Guys, I got to use all the information. I have to say if the angles are vertical, then they are congruent. If I flip it around and say if the angles are congruent, then they're vertical, you're saying every time you have congruent angles, they have to be vertical. And that's false. So let's write this out. If the angles are vertical, then now can I use they here? Do I already know what I'm talking about? And I do. I'm talking about the fact that the angles are vertical. Then they are congruent. All right. It says identify the hypothesis and the conclusion. So when I circle this, I do not circle the if or the then. I'm going to abbreviate it. Hypothesis and conclusion, H and C, and state the truth value. So if the angles are vertical, then they're congruent. Is that true every single time? And hopefully you're saying it is. It is a theorem. This is they are always congruent. This is true. Next up, parallel lines have the same slope. Oh my guys, we're going back to Algebra 1. So do you remember anything about parallel lines and slopes? All right, so we're not only learning about geometry, we have to remember algebra now. So if you remember, parallel lines actually do have the same slope. If they're perpendicular, you take the slope, you flip it, and you make it the opposite sign, like you make it from positive to negative or negative to positive. But if they're parallel, they're exactly the same. So let's see how I wrote this here, because the original is not in conditional statement form. So I said, if the lines are parallel, then they have the same slope. Again, I can use they in the second part if I've already established who they is talking about. We need to decide if this is true or false. If the lines are parallel, then they have the same slope. And like I already said, this is true. And I forgot to label my hypothesis. Let's do that. And my conclusion. All right, number 3. This is a tricky one. Now, if you can go to the movie if you take out the garbage. Notice the word if is halfway through. It's going to be similar to this example here that we had about if you play football and you're the quarterback. So there is a if. So we're going to say if you take out the garbage, comma, then you can go to the movie. Now, the sentence is great. I can label my hypothesis and my conclusion. Here's the part I have trouble with. Nothing about taking out the garbage has to do with going to the movies. So can you technically prove that true or false? And for this one, I'm going to say no. I put a question mark here. Technically, I can't prove this one true or false because we have no knowledge of if taking out the garbage means you automatically go to the movies. If I had to say, I'm going to say false because I have taken out the garbage and I didn't go to the movies. So if something like this happens, you can explain your situation. I would, on this one, if I had to pick, I would say false because there's many people that don't go to the movies because they take out garbage. Number 4, All squares have 4 sides. So we're back to math things. That's good. All squares have 4 sides. So we need to start with if, in the middle have a then. Now, I like to use the word figure a lot of times. Instead of saying if it is a square, again, what's it? I can say if the polygon is a square, if the figure is a square. All of those words are good replacement words. So, let's see. If the figure is a square, then it has 4 sides. Identify your hypothesis and conclusion. We have to decide if it's true or false. So every time it's a square, does it have 4 sides? Which is a different question than saying if it had 4 sides, is it always a square? So you have to be careful how you read it. I'm saying if it's a square, does it always have 4 sides? And that is 100% true. If it had 5 sides, it's no longer a square. All right, so I believe this is the last one that we're going to do together. Supplementary angles add to 180 degrees. Again, supplementary angles are 2 angles adjacent or non-adjacent that equal 180 degrees. This one is not in conditional statement form, so we have to do a little bit of work. I can go ahead and put my if down. So I can't try to talk, in a natural flow. You don't want to say if supplementary angles, then 180. We want to make it flow. If the angles are supplementary, then now we can use other words that mean add, like the word sum. Then they have a sum of 180. So you can, change it up a little. It has to have the same meaning when you're finished. So if the angles are supplementary, and want to abbreviate, then they, and I can say they because we already know who they is, then they add to 180 degrees. Okay, let's circle the first part for your hypothesis and the second part for your conclusion. All right, so this is day 1 of chapter 2. You need to complete this next part on your own. It needs to be math or geometry related. Please let me know if you have any questions. Goodbye.